Okay, hi guys, welcome back for our last example. Okay, so I'll just go through with you what this question talking about. I have do some working here. Okay, so later I'll talk about this. Okay, because I want to make the video as short as possible. So they say a particle starts from rest, blah blah blah. Okay, they give you one equation only, which is v equals to 8 plus cos t. Okay, let me try to zoom this part for you here so you can see. Okay, yeah, there. Okay, so they only give you one information, which is 4 plus cos 2t. They didn't give you t equals to what, v equals to what, a equals to what. So the question asking you several things. Find the range of values for the velocity, find the range of value for acceleration, find the values of t when the particle comes to an instantaneous rest, and then last one, distance traveled. Okay, so velocity we can do directly, acceleration you need to go down, and so and forth. Okay, so for question A, they give you the equation already. Okay, then ask you to find the range of values for the velocity. Okay, so they want to know the range of values for the velocity. To do that, first you need to do one declaration, which is this part here. Okay, so I'm going to close this. We have to do this declaration. Okay, I'll declare to you cos 2t is actually the lower limit is the upper limit is 1 and negative 1. In case you're wondering why, we have learned this in trigonometry. Okay, in trigonometry we learn this is the graph shape for cosine. So when we put the graph shape for cosine, this point here, what do we call that point as? Okay, we call that as the amplitude. So we have learned the amplitude has to be 1 and negative 1 by default. How the amplitude change? Okay, remember I say if let's say my equation is 2 plus cos 2t, then this whole graph will shift on top. If you don't see this 2 plus, that means the default amplitude is 1 and negative 1. So that means you see this is a default one. Okay, we ignoring the 4. Okay, we just concern about we want to get the range of values for the velocity. This is the first step. You need to declare whatever cosine function they give as upper limit and lower limit. Okay, so then what you do, you already know that the cos 2t is 1. So I'm going to declare here when my cos t equals to 1, I will replace this function here as 1. So 4 plus 1 times 4 plus 8 times 1. So 4 plus 8 times 1, I get 12. And moving forward for cos 2t, I declare negative 1 because another lower limit is negative 1. So this one is negative 1. So 4 plus 8 negative 1, you get negative 4. So that's leads you to this equation here, how you get the limit for the velocity. Okay, so this is the limit for the velocity. I repeat again, I think this one Miss Catherine already covered, but I will explain to you one more time. Usually when you have a cosine function and they ask limit, you have to do this step. Okay, no means no, there's no other way to do. Okay, and then for question B, they ask you find the range of acceleration. As you learn, acceleration is SVA at the bottom. So what is given to your velocity function? So from velocity you want to go acceleration, you're going one level lower. So one level lower means you have to differentiate. Okay, so what I'm going to do, I'm just going to teach you how to differentiate that. Okay, wait wait, let me get a marker first. Okay, so our equation is v equals to 4 plus cos 2t. Okay, so we need to differentiate this because we want acceleration. So I'm going to dv with respect to dt. Don't ask me how to differentiate this. You should know by now already. Okay, oh, there's the 8 there. Okay, so differentiate cos. Okay, you will get negative sine 2t, then differentiate inside 2, so that will give you negative 16 sine 2t, the function for a. Okay, so now you got the function for a ready. So now the next step is what you want to do. You want to find the range of value for the acceleration. Like I said earlier, you have to do a declaration. What declaration you need to do? You need to mention that sine 2t, the range has to be between 1 and negative 1, because remember sine graph is like this, right? So this upper limit must be 1, negative 1. So we declare. Okay? So now that we declare, okay? So let's do the declaration. So sine 2t equals to negative 1. So this one negative 1 means a equals to negative 16 times negative 1, we get 16. Then sine 2t equals to 1. So a equals to negative 16 times 1. So you got negative 16. That means your acceleration upper boundary and lower boundary, your lower limit and upper limit will be 16 and negative 16. Okay, so done lah. Okay, part A and part B we done already. Now we're going to look forward to part C. Okay, so in part C they say find the values of t when the particle comes to an instantaneous rest, value of t. So they say instantaneous rest. What do instantaneous rest means to you? What does it ring a bell? Okay, when a rest happen, okay, see there's this topic heavily tied with your physics. Okay, if your physics is not good, there's an opportunity for you to learn. Don't ask me to explain the theory of physics. Okay, I'm not going to do that here. Okay, so when a particle comes to a rest, that means your velocity has to be what? When a particle comes to a rest, that means your velocity has to be 0, Because velocity talk about movement, right? Okay, acceleration is how fast it's going. So velocity talk about movement. So when it's resting, there's no movement there. There's no physical movement. Means your velocity has to be zero. So that's how you know you need to use back the velocity equation. Okay, because some student will get confused at this point of time. They'll be wondering, sir, how do I know I use velocity or acceleration? That's why your physics has to be good. Okay, so at instantaneous rest, if your physics not good, maybe you can learn to write keyword. At instantaneous rest, only one thing is zero, which is v equals to 0. So I'm going to declare v equals 0 and find what is the time where I take my rest or whatever it is. Okay, so v0 when rest, okay, instantaneous rest. So we shift the 4 there, we shift the 8 there, okay, and you do your drama lah. So cos 2t equals to negative 1 over 2, and then 2t equals to let's see. Okay, you have to shift the cos first. Okay, so when you do this, guys, come on, don't do trigonometry, where you know negative, you go find a quadrant and so and forth on it. Okay, what you can do, you straight away press in your calculator shift cos or 1 over 2 there, or something. Okay, so wait, I'm not pressing it correctly. Okay, so what I get is yep. Okay, so what you can do, you see, you straight away press shift cos negative 1 over 2. There's no need to find the other one, okay, because we are doing velocity, we're not doing finding possible. So you get 120. Okay, so 120 you convert to radian. How do you convert to radian? Okay, 120 there, 180 times pi. Okay, so that means it's 2 over 3 pi. Okay, so 2 over 3 pi, then you shift the 2 there, so t equals to pi over 3. So take note, when time equals to pi over 3, they are having a rest there. Okay, the first rest. That means you see this question say the particle start from rest moving in a straight line. So he start from 0, he travel, we don't know how long he travel, and then he take rest at this time. That means let's say like the same case Ali. Okay, Ali from here, he start here, he go, maybe he take rest here before he go to school. Maybe he stop here to buy nasi lemak, then he go school. Okay, oh sorry, you can't see. Okay, that means Ali from here, before go to school, he stop here, he buy nasi lemak, then he go to school. Something like that, the scenario. Okay, so that's question C we done. Now let's look at question D. Question D is a bit tricky lah. I would say it's a bit tricky. Okay, so they said find the distance traveled during the time interval 0 t and then pi over 2. Okay, they want to know what happened actually, what's the distance travel. Like I said, in SVA you need to get displacement. Okay, so you have to be careful. Like I say, because you get displacement, you have to find each and every value. So now you'll be asking me, sir, am I supposed to find each and everything or not? Okay, first you need to know pi over 2 is what. Okay, then only we can know what time we're talking about. So that means we're asking from 0 to 1.57 second. I'm going to write in decimal so that I can have a reference of what I'm doing actually. Okay, that means I want to know from 0 to 1.57 second what happened actually. If you notice, there's a drama here. You know what is the drama? Alamak, where's my paper lah? My paper is here. Okay, the drama here, you see, this dude take a rest in between. You know how I know in between? You see, pi over 3 is giving me 1.04 second. That means they're asking you for the total journey, but in 1.04 this dude had a rest ready. I repeat again, you see the question, they say 0 to 1.5. That means the whole journey they're talking about 0 to 1.5 second. But in between, this fella take a rest ready. So we need to know after the rest what happened. Whether he continued to school or he ponteng from school. Okay, I repeat again. You see, the question says 0 traveling to 1.5. So that means assumption from 0 to 1.5 he traveled to school. But now the truth already prevail, saying that at 1.04 this dude make a rest. So we need to find out, investigate whether at time 1.04 he go back to school at or not, or he ponteng sekolah. Okay, that means bunk school lah. Okay, so let's discover that. Okay, wow, it's an interesting discovery. Okay, so for do that we need to use our velocity. Okay, we need to use displacement formula. So what we have is v equals to 4 plus 8 cos 2t. So we need to integrate to get our s here. So when we integrate, we get 4t plus, okay, alamak, you are very lazy to do this lah. Let me think. So you get sine 2t, then you have 8 here, then different, put here 4, and then plus c, I think lah. Okay, so that means it's 4t plus 2 sine, Oh, differentiate this, sorry, it's 2. So here should be, okay, let me cut the, so 4t plus 8 over 2, 4 sine 2t plus c equals to our, this thing, okay? This is our displacement equation, lah. As usual, you got c. So by now you should learn already. When you got c, what do? I told you already, in displacement, if time is 0, your displacement should be 0. So you declare, lah, t0 as 0. There's several declarations you need to do here. So 0 equals to, and of course you will ask me, sir, do I need to show the substitution or even though when I see I can get the answer? Yes, my answer is you have to show. Okay, so computing this thing, you will get your c as 0. Okay, very pointless calculation, but sadly you have to do. Okay, so you get ready. So now we can write our equation nicely before I start with the investigation whether this boy actually go to school or Ponteng or not. Okay, so what we do, of course lah, we put the pi over 3 inside to see whether he went home or not. So now I'm going to find what happened here. 4 pi over 3, I repeat again, you'll be wondering why I specifically put the pi over 3 here, because we have learned that at pi over 3 this due take a rest. Okay, so we need to find out that first. Okay, so you put this pi over 3 and then you compute in the calculator. You will be asking me, do I put radian mode or what? Okay, let me see what mode I put. I think I put degree mode. Actually can lah, doesn't matter. Okay, unless I mean no, you have to put in radian. I put in radian actually, but you can see, here. So what we got here, okay, you see I got something very weird. You know why? Because it's in a degree mode, so you have to go and put in radian, remember? Okay, so 4 bracket pi over 3, okay, and then plus 4 and then sine a sine 2 pi over 3. Okay, so you get 7.6. so this is the distance travel, 7.65. I'm just going to write here 7.65. how many decimal figure? Up to you. I want to finish fast. It should be 4. So at 1.0, I'm going to write here at 1 point, where's the calculation just now? At what? At 1 point, see, at 1.04, okay, this abang, okay, travel 7.65. okay, so he, after, that means from 0 meter he travels 7.65, then he stopped. So now after that we need to know whether this abang go back home or not. Okay, so I will do another calculation here using the pi over 2, because they want the all the way to pi over 2 okay, so s equals to 4t plus 4 sine 2t. So I'm going to sub my t as pi over 2 because that's the end point there, or the end game. Okay, so now we're going to know whether he went home or he went to bunk. Okay, so you compute this lah happily, for, see, you know why I show a calculator now? Because I realize some of you, I'm not saying all, some of you don't even know how to press calculator way. That's very, 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 very saddening. Okay, wait, just give me a second. Okay, I noticed there's some problem here. Okay, but never mind. Sine 2 and then pi over 2. Okay, so wait, 4 pi over 2, okay, plus 4 sine, oh, it's pi only because got cancelled off already, right? So it's pi only. So I get 6.28. see, I got 6.28. So case tangkap already. Okay, so let me explain to you in another color, because some of you don't even know how a displacement is measured. Okay, like I said, displacement is always measured from the starting point to the end point. So let's say I from point A I go to point B. Okay, I say this is 10 meter. What's my displacement for this question? Okay, my displacement is 10 because my start point and end point is the same. My total distance is the same. But what if from A to B, then from B to C, there's a drama happening. That means this is 10 meter, this is 2 meter. Okay, so displacement we always measure from start point to the end point here. Okay, so what I'm going to do now, if you notice there's something very weird happening here. Okay, what happened actually when we initially measure, okay, when initially the first time when we measure when t equals to 1.03 here, he took a rest, correct or not? So when he took a rest, see, I wrote here already. Okay, when he took a rest, what is displacement? 7.65. okay, that means from point A, okay, I don't know, you can, okay, from point A he traveled 7.65 until 1.03. okay, this is the displacement earlier. But after when we calculate putting the remaining time, we notice our displacement gets shorter. Okay, so our displacement gets shorter. So this is a problem here actually that we need to identify. So how do we know our displacement gets shorter? That means maybe, okay, he must be had to make a U-turn. He make a U-turn that the new displacement is 6.28 up to here. You notice the problem here now, okay? That means the new displacement here is 6 point, what we call that, 28. Okay, I repeat again, initially our displacement was 7.65. This is up to 1.03. So that means if he continue go to school, that means he didn't make a U-turn, he continue go to school, your displacement should increase. That means initially 7.65, it should plus and come 10 or 12 something. Okay, but now the problem, what happened, when you calculate your displacement gets shorter. Your displacement gets shorter means that means he make a U-turn ready. Okay, so what we need to do, we want to find the total distance travel, right? So first he traveled 7.65, and then now we want to know how much is this distance. So 7.65 minus this, we will get this. So your total distance here, okay, is 7.65 plus you minus this 2. Okay, I'm gonna minus this 2. 7.65 minus 6.28, so you get 1.37. Okay, so 1.37, and then truth prevail already that yes, he didn't go to school, he bunk already. So you get 9.02 meter. You understand? Okay, so I have to explain this one more time. Okay, it's a long video because it has a very important theory. You must understand how a displacement works. Displacement always measure from start point to end point. Like for this is a straight line. Okay, so your displacement, your distance is the same, but for here your displacement not the same, because why, start and end point already get shorter already, but your distance is still the same because you're going to make a U-turn, so and forth. So that's how we answer this kind of questions. Okay, so maybe I will upload all this later. Okay, so we have done the tutorial work example. What I'm going to happen is now I'm going to zoom out and I'm going to show you there will be few example that I will extract from this thing here. Okay, I extract some from here and then I'll put it, then you can do it lah. So if any question you can just ask me, I'll try my best to explain to you. Okay guys, okay, thank you, please come back to the Zoom. Bye.